It's a pencil sharpener in the back corner there, a nice electric one that I paid for out of my own pocket, so treat it nicely. People at home on the internet are going, say, what? You're ready. In physics, oh, by the way, Unit 1, Lesson 1, displacement and average velocity. In theory, some of this might just be review from Science 10. I'm going to assume you've forgotten it all from Science 10. Also, the Science 10 textbook does such a god-awful job. I'm going to teach this from scratch. In physics, every measured quantity, everything that we measure, is either a scalar or a vector. Anytime I introduce a new concept to you, I'll give you the symbol for that concept, I'll give you the units for that concept, and then I'll also tell you whether it's a scalar or a vector. Those things you will have to memorize, but those things you'll memorize because you'll be writing them out so often it'll just take care of itself. So as much as I don't like memorizing stuff, there is some stuff that's worth memorizing, but I'll try and build it into the course in such a way that most of the time you'll memorize it without trying. That's the goal. Scalars have magnitude only. Magnitude is a fancy schmancy word for size. Size. But size implies taking up space. Time is a scalar. It doesn't take up space, but it has a magnitude. How many seconds? Magnitude. Okay? For example, time is a scalar. Mass is a scalar. Volume is a scalar. Speed is a scalar. Distance is a scalar. By the way, we won't write these words out very often. For all of these, we're going to use one-letter symbols because I tend to abbreviate, and we do that in physics. Vectors have both magnitude, they have size, but they also have, Rylan? Thank you. And that direction becomes very important next year in Physics 12. This year in Physics 11, we're almost always going to keep everything in a nice straight line. And so in terms of direction, Zach, we'll usually let to the right be positive and to the left be negative. We'll let up be positive and down be negative. That's pretty easy. But in Physics 12, we'll start to have some things moving this way and some things moving that way. And how do you do math with that? I'll teach you vector mathematics. I might get to it by the end of this year. I don't know. Depends how smart you guys are. Some examples of vectors. Acceleration. It matters whether you're accelerating forwards or backwards. Makes a big difference. Those of you that have your driver's license hopefully have figured that out. Velocity. Mr. Dewick, how are speed and velocity different? Well, we'll talk about that. Force, it makes a difference which way you push on something. How hard you push does also make a difference, but which way you push also makes a difference. Momentum. And many others. Many things are scalars, many things are vectors. Scalars are nicer in some ways because the math is easier. For a scalar, 6 plus 5 is always 11. For a vector, 6 plus 5 might be 11, 6 plus 5 might be 1, 6 plus 5 can be any decimal value between 1 and 11. Say, what? A little preview of Physics 12, preview of coming attractions. So we'll have a little list of some of the ones we're going to look at for the next while. Scalar, we have time. And we're going to use, what would be a good letter to use for time? T. A vector, how about acceleration? I'm just going to abbreviate acceleration with accel. What would be a good letter to use for acceleration? We have under vectors velocity. Mr. Dewick, it would be very convenient if there was an easy way to remember that velocity is a vector. Mr. Dewick, if you were a good teacher, you'd have a dumb, easy way for me to remember that velocity is a vector. Yeah, I got nothing. Sorry, you're on your own. What would be a good symbol to use for velocity? Speed is a scalar? Mr. Dewick, it would be sure nice if there was an easy way to remember that speed is a scalar. Mr. Dewick, if you were a good teacher, you'd have an easy, dumb way for me to remember that speed is a scalar. I got nothing. You're on your own. What would be a good letter to use for speed? I tricked you. We also use a V. Huh? Patience, young grasshoppers, patience. Distance is a scalar. Displacement is a vector. They're related, but not the same thing. We have symbols for those too, but I'm going to give you those later in the lesson. In a textbook, if I want to show something as a vector, like velocity, it's written in bold font, but that's really hard to do in handwriting. So vectors are either written in bold font, or when we're handwriting, we put a little arrow above the letter, and that arrow, Alec, is meant to show this one has direction. In other words, that's speed, that's velocity. Although over the years we get sloppy, and instead of a full arrow, we just kind of draw half the arrow. You can, if you want to, put the other one there, but just over the years we get lazy. Oh, and so that acceleration up there should have a vector sign above it too. Mr. Dewick, will you take marks off and be... I won't take marks off and be fussy, but if you're sloppy, you'll forget and you'll lose the marks naturally on your own because you'll accidentally treat a vector as a scalar or you'll treat a scalar as a vector. So I will try and be careful all throughout my writing. Okay? Distance versus displacement. Distance is how far an object has traveled. Symbol. The proper symbol for distance, and this comes to us from the Brits, this comes to us from Sir Isaac Newton, this comes to us from a Latin word, is a lowercase s. I hate it. And the reason I hate it is because that looks an awful lot like that number, and especially when I write, my 5's and s's look the same. And also, a lowercase s is the units for time, seconds, and it gets confusing. So although that's the correct symbol, you will also see many textbooks use a letter X, a lowercase x. It'll come back, I hope still. A lowercase x for distance because of a graph. They're talking about the x-axis. I'm okay with that. In fact, I'm debating. I may switch to that in a couple of years. I need to talk to people that have taught physics for longer than me and that are wiser than me, and they need to convince me of it. I may swap to it. But at the same time, I'm not a big fan of it. You may see it in... If I borrow a handout from the internet, you may see an X as a symbol for distance because of the x-axis. Don't freak out, but I'm going to put an X through the X. I prefer, where possible, to try and use D for distance. That's wrong, technically. But it's easy to track. It's wrong for a number of reasons. Rylan, you're taking calculus this year? You're going to find out a lowercase d in calculus has a hugely, hugely important meaning that I really shouldn't be mucking around with distance, but in Physics 11, we're going to be nice and just use d for distance. Meters. Once in a while, we may live with kilometers, especially if we're looking at car speeds, because car speeds and velocities are typically in kilometers per hour, but even then we'll often just convert it. displacement. An object's change in position. Symbol. Well, technically it's an S with a vector sign. Don't write this down. We're not going to use that. Or it's sometimes an X with a vector sign, except we have a symbol for change in to. Does anybody know what the symbol for change in is? Yeah. Nope. You're on the right track, but yeah.
Would it be like a triangle for delta?
Oh, he gave me both. It's a little triangle. He didn't want to sound too nerdy. By the way, if you just said delta right away, my little math nerd heart would have said, I like that. Yeah, a Greek letter delta, little triangle like that. And so I'm not going to use that much either. I'm going to use this. But you know what? Often I drop the delta and just do that. Why? Because I'm lazy. It's a bad habit, but it's going to happen. So, okay. What's the big difference between these two? The vector symbol. Okay. When an object starts moving, it's useful to be able to describe an object's position or location. To describe location, imagine a meter stick is placed next to the object, and the meter stick sort of acts like a number line. There's 0. To the right is going to be, Zach? To the left is going to be? Now, that doesn't have to. There's going to be a couple of times later on this year when, just to make the math nicer, we'll let left be positive because it's just going to make the numbers nicer. There's no fixed rule. Just usually, when in doubt, I tend to fall back on imagining a big piece of graph paper or a number line. Okay? So objects to the right of 0 typically have positive positions. Objects to the left of 0 typically have negative positions. Example 1. We're going to imagine a little bug walking along this number line. It starts at A, walks to B, and then turns around and walks to C. You know what? We're going to draw a picture. We're going to go like this. And then from B, it turns around, walks to C. Question A. What distance did the bug walk? How far did the bug walk? How many meters did the bug walk? That's all the same thing. Yeah?
14 meters.
14? Let's see. 4 this way. 10 this way. Now, in your homework, if you did that in your head and wrote down the answer, I'm totally good with that. Here in our notes, let's just write that we went 4 plus 10 so that when you're studying later on, you know where the heck that came from. But feel free not to write that step in your notes. In your homework. What's the bug's change in position? Displacement. Yeah. Negative 6 meters, or you could say 6 meters left. Which version is shorter to write? I'm going to use the negative because it's less work. But if you say left, I'll take that. I would be fussy, though. If you said, don't write this down, negative 6 meters left, I would argue that negative left is actually to the, and I'd say, I'm taking a half mark off. One or the other, not both. Right? Left. He'll get that joke.
I got it.
Sure, whatever. We believe you. So, little thought experiment. Example 2. Suppose you run along 3 different paths from location A to location B. Along which paths would your distance be different than your displacement? Or if I reverse the question, along which paths would distance and displacement be identical in magnitude? In which one would your distance and your displacement be identical in magnitude? Yeah. So the answer to this question would be that one and that one. Okay. Example 3, use the number line below to give the positions of the objects. Don't forget units. So what is the position of the heart?
4 meters to the right.
Too much writing.
4 meters.
And if I write 4 meters, it's assumed it's positive. Yes, there is invisible positive. I'm good with that. You could say 4 meters right, and I'm fine with that too. Position of the diamond.
Negative.
Position of the cross. 0 meters. We would probably say that was the origin or the initial or the starting point, but maybe not. For some reason, they might have decided to start measuring at -4 or at +4. So that's talking about position. We said displacement was a change in position. We can use arrows to represent a displacement. So really, oh, I did use arrows up there on the bug question. Good. I was going to say, had I put arrows on there? A bike moving along a number line from a position of +4 meters to -3 meters, for example. We will often use a variable, x or d, to symbolize an object, and then subscripts, I for initial and F for final. My lowercase I, I'll almost always put a little curl on it like that, because in the back you might not be able to see the dot on top, Gracie, but if you see the curl, you'll know that's that's just a habit I picked up. I'll try and make the dots nice and big too, but sometimes it'll be like that. I don't know if you can see the dot on the I, but you can't see the little curl. Okay? We're going to use subscripts as shorthand. Draw an arrow, example 4 says, showing an object that moves from the -4 position to the +5 meter position. So, here is position initial. You know what? Let's use an X. Here is X position initial, XI. Here is X position final. Draw an arrow. You can freehand it if you want. Try and make it fairly straight. If it's a bit crooked, Mr. Duke, will you take marks off? No, but I will take marks off if you that. So don't do that. Okay. What's this object's distance? How far did it travel? What's this object's displacement? Oh, you know what? I'm going to go D equals, no vector sign. Let's start doing proper statements here. What's this object's displacement? And here, I would probably read it out as +9 meters to emphasize that there is a directional component. Or you could say verbally 9 meters to the right, but I would write 9 meters and know there's a plus sign there. Example 5 says, draw an arrow showing an object that moves from the 7 meter position to the 1 meter position. What's the object's distance that it traveled? Nope. Negative implies a direction. Distance is, he said -6. -6 includes a direction. Distance is a scalar. What's the distance? Just plain old 6 meters. What's the displacement? What's the change in position? That would be -6 meters or 6 meters left. But don't say -6 meters left. So far, so good. We're just giving you some terminology. Good yawn? You're awake now? You're back? Excellent. Speed versus velocity. Average speed is the change in distance over time, where that delta means change in. As an actual equation, we would say this. The symbol for velocity without a vector is speed. My abbreviation for average is that as a subscript. There is a symbol for average. The symbol for average is a horizontal line, but that looks so much like the vector symbol from the back of the room, I tend not to use it. I just do a subscript of average instead, so I can do that. And that equals the change in distance over time. What would the units be? What do I measure distance in? Per. What do I measure time in? It is worth memorizing what units go with what variables or what concepts. Have I already told you I hate memorizing things? If I tell you it's worth memorizing something, it's really worth memorizing something! Trust me. Trust me. If you memorize what units go with what things, you will cut down on your mistakes and your thinking dramatically. Dramatically. So it is really, 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 really worth memorizing. Oh, speed, meters per second. That way, if you see a number and next to it you see meters per second, you instantly know it's a speed. Don't have to think. Speed, scalar or vector. It'd be neat if there was an easy way to remember that speed was, sorry? Turn the page. Average velocity is displacement over time, where that triangle means change in. As an equation, we would say this. Velocity av. That's the other reason I don't use the average symbol, because the vector arrow is up there now. Equals that. By the way, it's also technically change in time and change in time, but because time is always a change in, we get sloppy, we get lazy, and we tend to drop the delta. What would the units for average velocity be? Well, what do I measure displacement in? What do I measure time in? Mr. Dewick, if I see meters per second, how can I tell whether it's a velocity or a speed? Oh, if there's also a direction, it's a velocity. 30 meters per second, speed. 30 meters per second north, velocity. Velocity, scalar or vector?
Vector.
Be neat if there was a dumb, easy way to remember that. So let's start to apply some of this. We're good? Figured out where we are? I know, the photocopier kind of does things weird. If the bugs trip mentioned in example 1 took 30 seconds, so if time equals 30 seconds, let's write that down. And from example 1, I'm going to scroll back. Example 1. The distance was 14, the displacement was 6. Over here, let's write distance was 14 meters, displacement was 6 meters. Okay, now we've got our data. Part A says, what's the bug's average speed? Okay, so when I'm solving physics questions, until I get good, I tend to use an approach that I call DFIC. It's an acronym. You can kind of put it off in the margin there somewhere. And the acronym DFIC stands for list your data. We did that right there, but I always do that first. Then I find a formula or an equation. Right now you only have a couple of equations, so it's going to seem pretty obvious, but by the end of the year you'll have many. I insert the data, and then I crunch or calculate the answers. When in doubt, DFIC. And I'll show you how I would do that. Now, probably you'll get good enough at these questions that you can skip some of these steps. But for starters, I would say to myself, what's A asking me to find? What is A asking me to find? I would write down V equals question mark. I've written something down. I feel better. My question's no longer blank. And I just identified what I'm being asked to find. Then I would say, what else have they told me? I've already written down what they told me here. But if not, if I hadn't done that, I would scan the question and I would look for numbers and physicsy words. Write those out. Then I look for an equation. Hey, what's the equation for average speed? I think I said average speed was the distance over the time. The change in distance over the time. Distance over time. Meters per second. It's going to be 30. What was the distance?
42 meters.
$14 divided by 30. What's that? Mr. Dirk, how many sig figs? Well, we just finished a unit on sig figs. We're dividing. How many sig figs is 14?
2.
How many sig figs is 30?
1.
Technically, I should go to 1 sig fig. I'm not. I'm going to go 0.467, just so that you know what we got on our calculator, okay? 0.467 what?
Meters.
Meters per second. Okay. Average speed was 0.467 meters per second. What would the bug's average velocity be? Well, velocity average is displacement over time. Now, sometimes, Angela, your displacement and your velocity will be the same value. Not always, but sometimes, especially if you go in a straight line and don't change direction at all. Okay? Which means sometimes you'll get the same magnitude answer for average speed and average velocity. It's just that the velocity will have a directional component. I didn't give, oh, yeah, we do have direction. The displacement was 6. The time was 30. 6 divided by, I think it's 0.2, double check. Here I sig fig. Meters per second. Direction. What direction was the displacement? In fact, I wrote down my data written down -6 meters. I should have put a -6 right there. So up here, let's make that a little better so that the negative is separate from the equal sign. -6 meters. And so I could either say that, or I could say 0.2 meters left or west. You know what? I didn't define whether east and I just left works on the piece of paper. Alejandro, every time I give you an equation, really what I'm giving you is several different equations. And one of the skills I'm really going to push, I'm really going to teach you to do is how to rewrite equations in your head. Rylan, is it helpful to be able to rearrange equations in your head and not have to memorize all of the variations? It's going to seem a little bit weird at first. I'm going to be teaching you to do math with letters, algebra. But if there's one single handy skill I'm going to push you for this year, it's that, and it'll drop your memorization by about 75%. You'll have to memorize about 3/4 less than you normally would. It's a win. So, if V average is displacement over time, what would be an equation for displacement and time? Well, an equation for displacement would have that by itself. An equation for time would have that by itself. Catherine, you okay with that? Thumbs up. how would I get the d by itself? See the d right there? What else is sitting on the same side as the d? What letter? What variable? T. What is that t doing to the d? Adding, subtracting, multiplying, or dividing? So how would I move it to the other side? I would do the opposite. Multiply. You know what? D equals VT. I'll put the average there. There's a whole new equation. I'm encouraging you not to memorize that. I'm actually going to say, if you can, if I give you this one, you can derive this one in your head. Now, I want to get the t by itself. Here the t is on the bottom, which is kind of yucky to deal with. Wait a minute. Here the t is on the top. What else is next to the letter t here? Average velocity. What's average? What's the v doing to the t? Adding, subtracting, multiplying, or dividing? How would I move it over to the other side to get the t by itself? What was already on the other side? So the d drops down like a domino, stays where it is. But you're telling me I would divide. There's another equation. I'm really going to push this method of being able to rewrite stuff. And if it seems weird at first, please trust me. Don't quit on me. You'll all be able to do a lot of these in your head. Okay. A motorist travels 350 kilometers during a 6-hour period. What was his average speed in kilometers per hour and meters per second? What does this question want me to find? I'm going to defic. I'm going to list my data. What else have they given me? Now I scan the question for numbers. I see a 350. What are the units next to the 350? So what is that 350? I think it's a distance. Now, it's not in my preferred units, but that's okay. I'll muck around with that later. I keep reading, then I see a 6. What are the units next to that 6? Hours. What's that 6 a measure of then? I'm looking for an equation that has a v, a d, and a t in it. There is one, because you only have one right now. V equals d over t. Okay, fine, the average. Now, normally I might convert these to meters and to seconds, but what units did it want for the first speed? So I think I can plug this in. It's not my preferred metric. It's not my preferred SI standard units, but it is how they measure speed in cars, so I'll live with it. It's going to be 350 divided by 6. $58.33333. So I'll write 58.3 repeating. By the way, technically, how many sig figs is 350? How many sig figs is 6.0? So you know what? Let's also go equals 58 kilometers per hour. I would live with 58.3, but really it is to 2 sig figs. Let me pause the video for 1 second here. Okay. Hey, let's call this Part A, and let's call this Part B. Let's be organized. It wants also an answer in meters per second. Yes? Okay. I can do this in 2 ways. I could convert this to meters. I could convert this to seconds, and I could redo this whole question, and that's fine. But maybe I can do a unit conversion and get there in one fell swoop. I'm going to try that. I'm going to write down what they gave me, which was 58.3 repeating kilometers per hour. This is a review of what you had on your test. But this particular unit conversion occurs so often, we're going to come up with a shortcut, and we're going to add it to our green formula sheet. So you might want to get your green formula sheet out. Kudos to those of you who already had it out and are starting to notice where some of these equations are. Let's get rid of the kilometers first. Where is the kilometers in the original fraction, on the top or on the bottom? So I'm going to put it on the bottom, and I'd like to end up in meters. I replace the K with what? And that would do that. Then I want to get rid of the hours. Where is the hours in the original fraction? So it's going to go in the conversion factor on the, and I'm going to go straight to seconds because I know that 1 hour is
3600.
By the way, 10 to the third is 1,000. So really what you're doing is you're timesing by 1,000, dividing by 3,600. We're going to combine that in one step on the next page. But for now, let's actually get an answer. So I still have this on my calculator. Hopefully you know where your answer button is. My answer button is shift negative. A lot of you it'll be shift or second function equals, or you might have a dedicated answer button. But I don't want to use the 58. I don't want to use 58.3. I don't want to use 58.33. I want to use the number that's stored in my calculator, which is 58.3 repeating. So I'm going to take that, and I'm going to go answer button times 1,000, 10 to the third, divided by 3.6, and we get,
36.
golly. Okay, I got to go back twice and fix this now. Let's try that again, Mr. Dewick. Got that stored on my calculator. I'm going to go times by, answer button, times by that, divided by 3,600. Thank you. And I get 16.2. Yes? Or if I go to 2 sig figs, 16 meters per second. I want to combine that 10 to the 3 and that 3,600, and it turns out you can. It's the same as dividing by 3.6. So, top of the next page, I'd like you to write a little kilometers per hour right there. Leave a space. Write a little meters per second right there. And then over here you can write the word shortcut. We're going to add this to our formula sheet in a second too, but don't do that yet. Just put this on the page first. I want to show you how it looks so that we do it right on our formula sheet and don't make mistakes. To go from kilometers per hour to meters per second, it's divide by 3.6. What about if I wanted to go from meters per second to kilometers per hour? Well, you wouldn't divide by 6. What would you do instead? If you want to, you can put this little loopy archy thing on the bottom of your formula sheet on the front page. I'd put it on the front page because you'll be using it fairly often. Although, honestly, a lot of you will get so sick of looking that shortcut up that you'll just memorize it. It's the 1 unit conversion that we'll keep doing because car speeds and highway speeds are in kilometers per hour. Physics speeds are in meters per second. And so, okay. So we've got an equation, V equals d over t, or velocity equals displacement over time. Let's look at some applications. Speed of sound is 330 meters per second. It is. Sheldon is shouting at the base of a steep mountain. If the mountain is 420 meters away, how long will it take before Sheldon hears an echo? Or if you time how long it takes you to hear your echo, you can figure out how far away the mountain was, which is kind of nerdily cool. What's this question asking me to find?
Probably time.
T equals question mark? What's that 330? How do I know it's a speed? Two ways. It did say the speed, but I actually looked at the meters per second and went, oh, speed 330. I'm not fussy if you put the units next to your data listing. I usually do, but you'll find as the year progresses, I'll stop because I'm lazy. What's that 420? Why is this wrong? Because it is, and there's a candy if you can spot why that has to be wrong. Even if I put meters there.
Negative.
Nope. Nope. Because it's a distance. We're doing Scalarville here. That's okay. Why is that not the distance that the sound is traveling?
That's not really the same
Now pause. Anybody see it? Kiana.
Because it has to go to the mountain and then back.
What, Kiana? Speak to me, oh brilliant one. Loud and proud for a candy. What was that?
Because the sound has to go to the mountain and then come back.
So how far is the sound actually having to travel?
840.
Or can I just do that? I like this question. I like this question. I like this question. I like it, first of all, because I don't know about you. I'm an echo nut. If I'm somewhere like at a viewpoint, I'm always trying the echoey thing. So it satisfies my little inner child. I like it because, hey, we're using the new equations. And I like it because you can't just barf the numbers into the, you have to think a little bit. Okay? Good catch. I'm looking for an equation that has a t, a v, and a d in it. There is one. It's this one here. But I want to get the t by itself. How? Where is the t right now? Bottom. Yuck. How could I move it to the top? Well, dividing by t on the right-hand side is the same as timesing by t on the left. Mathematically, those are identical, Matt. They are. Now, how would I get the t by itself? What else is next to the t? The v. I know most of you never want to break TV up, but we're going to have to live with it. How would I move the v over? What's the v doing to the t? Adding, subtracting, multiplying, or dividing? So if I hear you all correctly, you're telling me an equation for time, the d just stays where it is. It drops down like a domino. But I would end up dividing by the v. You see how we derived that? That is a much, 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 much better way, Nick, than memorizing these equations. And it's going to seem a little weird at first, but trust me, eventually you'll be able to look at something like this. You'll glance at it and you'll tell me, oh, that also means that d equals vf squared minus vi squared all over 2a. And you'll be doing that almost in your sleep. It looks intimidating now, but I'll get you there. If you can do that in your head, I'll let you do it in your head without showing any work. Now we're at the plug and chug stage. Or in my DFIC, we listed our data carefully. We found an equation, rewrote it. Now we're going to insert the numbers. D, 840 divided by 330. By the way, Kiana, the other thing we could have done is plugged in the 420 and then at the end doubled our time. But somewhere we got to double the distance or the time. $2.5454545454. I'm going to write 2.54 repeating, and now I'll go to the proper number of sig figs. How many sig figs should I go to here?
2.
So 2.5 seconds. Number 9. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, seconds, I can't do math with different units. I'm going to have to do a conversion somewhere here. How far will he travel in kilometers? In meters. Okay. What's this question asking me to find? D equals question mark? What's that 18? And because there's wonky units, I'll definitely write them here. Seconds and hours in the same question. That's like fingernails on the blackboard. Ugh. What's that 2.5? Okay. I'm looking for an equation that has d, v, and t in it. There is one. It's this one. But I'd like to get the d by itself. How? What's the t doing to the d mathematically? Adding, subtracting, multiplying, or dividing? So how will I move it over? Multiply. So we're going to get this. If I got the d by itself, the v was already there, and the t gets tacked on. If you wrote tv, I wouldn't mark you wrong, but traditionally it's written vt. Why? Because it is. And you'll notice, have they given me any directions in any of these? I'm doing these as scalar equations, although if you put a vector sign, I would say, hey, there is no direction. 18 what? 2.5 what? Ugh. You know what? We could convert this to seconds, or we could convert this to kilometers per hour. Either is fine. Wait. What do they want my answer in initially here? Then you know what? Let's convert this to kilometers per hour, because that should give us an answer in kilometers. Hey, there's a handy dandy schmandy shortcut. How do I go from meters per second to kilometers per hour? I remember it had something to do with a 3.6. Is it times or is it divide? Multiply? So I'm going to go 18 times 3.6, and 64.8 kilometers per hour. Now, I can do something kind of cool that you guys can't, in that I can just move stuff over and get more room. Sorry. So, 64.8, 2.5, 64.8 times 2.5, 162. 162 what? Kilometers per hour? Just plain old kilometers. I will be fussy on units. And they also wanted the answer in meters. How many meters is that? Have you guys figured out the easy way to go from kilometers to meters? It's times by 1,000. You have those shortcuts, you don't have to use my unit conversion chain or anything. You can, but I've memorized that it's in fact, you know what? I can do that in my head. 162 times 1,000 is going to be 162,000 meters. By the way, technically, how many sig figs? How many sig figs? How many sig figs? I should have gone 160 and 160,000. I'm not going to be fussy on sig figs for the remainder of the year. I tested. I'll always remind you whenever I can, but I'm not going to be fussy. It's because I'm making up data. Yeah.
Okay, if you went to seconds and converted to kilometers.
Yep. I think you'd end up doing slightly more work, though. All right.
That's more multiplying and dividing. So.
Example 10. An object can have a positive distance while having a displacement equaling 0. True or false? You know what? We're going to vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Dewick will make fun of me if I don't vote, and he will. I'm positive. I'm pretty sure. Totally guessing. So an object can have a positive distance while having a displacement equaling 0. Who says true? Absolutely. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Is that a hand up? Wow, 21. Who says false? 1, 2. Who didn't vote? You have to vote. Okay, so I'm going to put you down as falses. Still 2 of you didn't vote. I'll get you next time. And then I will be doing this fairly often. I'll be asking us to vote. And then I always say you can attack or defend. You can defend your answer as having to be right, or you can attack someone else's answer as having to be wrong. Convince me. If you voted true, convince me. If you voted false, convince me. An object can have a positive distance while having a displacement equaling 0. And usually to convince me, give me an example. Yeah.
Could end up reaching the same point where it started.
So you're saying, as an example, go 5 meters forward and 5 meters backward. Oh, sure. If in fact, if you wanted to do it generic, go X meters forwards and X meters backwards. Sure. Okay. So, true. Yeah. All right. Smarty peoples. An object can have a positive distance while having a negative displacement. True or false? Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. I'm positive! I'm pretty sure. I'm guessing, but I'm going to vote. So an object can have a positive distance while having a negative displacement. Who says that's a true statement? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, well, you know what we're going to say? Lots. Who says, nah, it's false? No one. Convince me. Someone besides Jason, because he got the last one. Tato.
You can start negative and move forward, like you're not. You can move forward, but not to be positive again. Like if you start with -6, you can move forward, you stay at -2.
So Tato says start at -6 meters, move to 2 meters. Does that work? That has a positive distance. Doesn't that also have a positive displacement?
Oh yeah, I lied.
It could be like a racetrack where if you started at one point and go around, then you end in before where you started. It'd be easier to go backwards for negative displacement, but you've also moved positive displacement.
How about, can you give me that on just even on a number line?
Probably like no, you can't. Maybe
Let-
start at 0.
How about start at -2 meters, go to -5 meters. What's your displacement? 3 meters to the left. What's your distance? 3. Did you say 3? Which is a positive number. Okay.
Oh, doesn't matter.
Distance is a scalar.
Doesn't matter. Yeah.
Good. Now that oh is what I wanted you all to get. That there. Okay. By the way, we're going to go right to the tone. You're not going to have any homework. And I don't see you again for the rest of the week, which is kind of stupid, but okay. Friday is a day 2-4 for some dumb reason. Yeah, but it's not. Anyways. On Monday of next week, we'll be doing a lab, and you'll have time to work on this homework in class. An object can have 0 distance while having a positive displacement. Alec, your racetrack idea intrigues me. How could you have, or can you have, 0 distance while having a positive displacement? Who said no? Convince me. Oh, by the way, I think I forgot to circle the answer. Oops. I think false. I think you can have a positive distance while having a zero displacement. In fact, technically, race cars, their displacement is always going to be zero because they start and end at the same location. Their distance is like several hundred miles. But that's not how we measure it, though, right? Yeah, Jason.
You can't have a change in position without moving.
You know what? I'm going to handwrite this because I don't know how to do a delta. Can't have delta D without moving. I love Foxtrot comics. Foxtrot comics are written by a guy named Bill Ammond. Bill Ammond actually has a physics degree, but while he was also doing a lot of doodling and drawing, and some of his friends said, hey, these are pretty funny. So he writes the Foxtrot comics. The young boy, Jason, is the young nerdy science kid who I emulate with, and here's his older brother, Peter, and they're playing football. Jason is giving Peter a football play to run. So Jason says, okay, here's the play. Go 40 yards downfield and turn left and go and go 20 yards. Then turn right and go 25 yards. Then turn right again and go 30 yards. Then turn right and go 30 yards. Then turn left and go 10 yards. Then turn left and go 15 yards. Then turn left and go 20 yards. Then turn left and go 50 yards. I'll hit you with the ball. Peter thinks for a little bit. Won't I be right back where I started? Jason says, I can't throw very far. Okay, here's a new play. I never get to be quarterback. What distance will Peter run in order to complete this play? By the way, I have before run this play on the football field, and you do end up back where you started from. The physics in here is correct. What distance will he run? Well, 40 yards downfield, plus 20 yards, plus 25 yards, plus 30 yards, plus, I'm going to the next frame, 30 yards plus 10 yards plus 15 plus 20 plus 50. I think I got them all. 40, 20, 25, 30, 30, 10, 15, 20, 50. Faster than you guys on your calculators. 60, 85, 115, 145, 155, 165, 170, 190, 240? Yes? And this is yards, stupid measure. Well, football. Okay. And here's the trick question that we're going to finish the lesson off with. What will Peter's displacement be?